Okay, first sedimentation. There are two types of sedimentation. Audible? Am I audible?
Yes, ma'am.
Am I audible? Okay. There are two types of sedimentation process. First process is the plain sedimentation and another process is sedimentation with coagulation. Okay, so first of all, I will explain plain sedimentation. To what we can say plain sedimentation, when the impurities are separated from a suspending fluid by the action of natural forces alone, by the action of natural forces alone, or we can say by simply gravitational and natural aggregation method. This process is known as the plain sedimentation. म्हणजे कुठल्याही प्रकारचं केमिकल न वापरता we are allowing to settle down the particles at the bottom. Suppose this is a tank, okay, and here we have provided the inlet and here outlet is provided. When water is coming through this channel, it will fall down, and you can assume now this is filled with completely filled. Okay, so when it is coming and passing towards the end at that time, because this is a channel, small area, and here in this tank, this is a section you can say. I will show the plan, how the plan will be there. Okay, this is a plan, or simply it is a rectangular sedimentation tank. Water is coming through this channel, means this channel, where area is very small, and when it is coming into this portion, suddenly the area is increasing, is it? And hence the velocity dropping down suddenly. And because of the dropping down of the velocity, slowly when it is there is a moving towards the end side, at that time it will start falling down the discrete particles or the individual settling, whatever by their own mass and weight, the particles will start settling down at the bottom. Okay, so this is known as the plain sedimentation, or in a, when you are talking in a scientific language, in a settling, it is a discrete particle settling. And another type is of sedimentation is the sedimentation with coagulation. So to increase the efficiency of settling, it will take time, lot of time, this process, plain sedimentation. But when you are performing this by applying some coagulants here, at that time, it will start clogging together with faster rate, and it will start falling down the particle with a faster rate. That process is known as the sedimentation with coagulation. Okay, understood? Sedimentation is nothing but simply I can define when we are reducing the velocity of flow and allowing to settle down the particle in a plain sedimentation. And in a sedimentation with coagulation, chemicals are added to induce or to hasten the aggregation process of particles and settling of finely divided suspended particles at the bottom. That is sedimentation with coagulation. Understood the two concepts of sedimentation. One is the plain sedimentation, jitha we are not providing any chemical. Simply we are reducing velocity, and because of the its own mass or own weight, the particles start settling down at the bottom. That is known as the type 1 settling or the discrete settling, or we can say it is a plain sedimentation. But when the particles are very fine particles and these are not going to be settled down, instead of that, it will flow along with the water. At that time, we need to convert, we need to increase the size of that particles. And that can be possible by addition of coagulants at the start. And when you are adding coagulants and allowing to flow it along with water, then agglomeration process will start, means multiple particles will come together and becomes heavier, and because of increasing weight again, then that they will start settling down at the bottom. That is known as the sedimentation with coagulation. कळालं का? कळालं का? कळालं का? I'm asking whether you understood or not. Okay, good. Thank you. Then next point, we will see types of settling. There are 4 types of settling. First one is the discrete particle settling, which I have explained just now. Particle settles individually without interaction with neighboring particles. Without interaction with neighboring particles, that is known as the discrete particle settling. Then the type 2 settling, flocculent particles, means flocculation causes the particles to increase the mass. Whenever we are adding coagulants, the flock formation process starts. And because of that flock formation, the mass of individual particles starts increasing, and then it will settle down at a faster rate at the bottom. Then the type 3 settling. Type 3 settling, or it is also known as the hindered settling or the zone settling. The mass of particle tends to settle as a unit with individual particles remaining in a fixed position with respect to each other. Actually, what happens here in this type of settling, actually, this is not for your syllabus. Simply you understood the title that type 3 settling is a zone settling. The mass of particle tends to multiple particles coming together and converting it into one unit with, and then that block of that entire material starts settling down at the bottom. Means zone wise, at the bottom there will be a little closed, the particles will be more close to each other. Then in the little upper side, there will be a more space between two particles. Likewise, the space between two particles will keep on increasing up to the surface. Means you can say type 3 and type 4 are one and same. Means here compression, the concentration of particle is so high that sedimentation can only occur through compaction of structure. I will show you this with figure. I will explain. Suppose this is a glass, okay, jar filled with the water. Filled with the water, and the particles are present into water, and we have applied chemicals, that is coagulation is also done. So what happens in these two methods, the coagulation process, when you are adding coagulant, at that time the coagulation and sedimentation process starts together. So whatever the particles settle down at the bottom, they will be in a dense form. They will be very close to each other. They will be in a compressed form. Then in a second zone, when you will observe, there will be a space between these particles. Little space you will observe in the second zone. Okay. Then above that, when you are observing, a more amount of space, wide space between these particles, you will be observing. Okay. So this is known as the zone settling or compression settling, when the same terminology is there. Okay. So you need to focus only upon the discrete particle settling. You need to focus only upon the discrete particle settling. Now we are going to study in detail what is the discrete particle settling. You can see here a discrete particle settling in a type 1 sedimentation. Type 1 sedimentation is concerned with the settling of non-flocculent discrete particle from water. When a discrete particle is placed in a quiescent flow, it will accelerate until impelling force F1 acting on the particle. Okay, very properly it is mentioned. So here is the tank which I have already also earlier also shown to you. Okay, the water is coming into this tank through this. Assume that this is a filled tank, completely filled tank. Okay, assume this. Now water is entering here when the particle is placed into this quiescent flow. I am saying, okay, when the particle placed in a particle is placed in a quiescent flow, it will accelerate until impelling force or driving force acting on the particle. When particle is placed here, there is a driving force acting upon that particle, and it will be keep on accelerating into the tank until the impelling force is acting upon it. Okay, and this particle will be keep on flowing until the driving force is forcing them to move, and as it is moving forward, the driving force starts decreasing and it may goes fall down. So what is the next terminology? What is the else making to settle down this particle? Let us see. First, remember, only you can remember, just you can remember that when particle is placed in a quiescent flow, it will accelerate until the impelling force is acting on the particle. Okay, now see in the second slide. At this stage, the particle attain a uniform terminal velocity and settle down with this. Actually, one sentence is missing over here. What was that sentence? What should be that sentence? So let me check. Actually, this sentence should be like this. It will accelerate until the impelling force acting on the particle. And when the particle settles down, when the impelling force and the drag force becomes equal into that particular tank, or we can say drag force, driving force and drag force becomes equal. At that stage, the particle attain a uniform terminal velocity and it starts settling down with this constant velocity, and that constant velocity is known as the settling velocity. At this stage, one sentence is missing over here, and that's why it is, you are feeling that it is incomplete. Again, I will explain. When the particle placed in a quiescent flow, it will accelerate until the impelling force or the driving force is acting upon the particle. As there is a this is a tank, and when it is placed, the particle is placed in a quiescent flow. When it is moving towards, it is moving because the impelling force is acting upon that particle. But at the same time, a drag force is also applying, and that drag force is making to settle down this particle at the bottom. So when this particle will get settled down, when impelling force is equal to the drag force, at this stage, the at this particular stage, particle attains a uniform settling velocity. At this particular stage, particle attains a uniform terminal velocity, and that terminal velocity is known as the settling velocity, where the particles will get settled down at the bottom. Okay, so this is the concept how the particles are getting settled down in a what we can say plain sedimentation process, or in a discrete type of settling process, or in a type 1 settling process. So I request this part write down first, and then the connecting statement which is missing over here in this presentation, I will tell you, and then we'll go to the next point. Okay, write down type 1 or the discrete particle settling. I think it's a 3 o'clock, 3:05. Okay, so I will try to conduct the next session on the board. I will see whether possible to make an arrangement. So this derivation I can explain properly on the board instead of this, or I will try to get the slate if available. Okay. So either of these, I will make arrangement. So you will be able to understand this, what I can say, derivation. We are going to solve one derivation over here under this discrete particle settling. And then subsequently, we will solve the design problems on the settling process. So for both of these, I will try to arrange the slate or board, so you may understand in proper manner. Okay. Attendance is very low, guys. Just 23 students are there. Over. Okay, thank you. So continue this. Type 1 settling is concerned with the settling of non-flocculent discrete particle from water. When a discrete particle is placed in a quiescent flow, it will accelerate until impelling force F1 acting on the particle. Okay, acting on the particle or equal to the drag force. Simply you can write or equal to the drag force. Continue acting on the particle, continue from here, or equal to the drag force, or equal to the drag force. Only this line is missing. Okay, then continue here. At this stage, the particle attain a uniform or terminal velocity and settles down with this constant velocity known as settling velocity. Okay, known as settling velocity. Which two forces are becoming equal? That drag force and driving force. When becomes equal, at this stage, particle starts settling down. Okay. Now we'll see that what is this impelling force. Okay, that impelling force is usually we denote the impelling force by the equation F1 is equal to rho s minus rho into g into v, where rho is nothing but the density of fluid and rho s is nothing but the density of particle. Rho s is the density of particle and rho is the density of fluid. Here fluid is the water. Okay, then we have taken volume of particle and it is taken pi by 6 into d cube. Why it is taken pi by 6 into d cube? Because in a sedimentation process, usually in a spherical volume of part with the formula pi by 6 into d cube, where d is the diameter of that spherical particle. Understood? So when we are equating these two forces, then we will get the settling velocity. Okay. So this is one big derivation. I will not complete this complete derivation because I will try to arrange something else to make you learn properly. But fundamental part we will finish here today. So here you can write down this slide also. And then I will explain one more slide and then we will stop. And in the next lecture, I will solve that derivation on the board. Okay. So write down. लगो सभी सर चहा पहले गेले पण कुलपला ना Done? Over? Okay.
Yes, ma'am.
Yeah. Thank you. So here we are, we saw this is the interlink force. Okay. Now the drag force. What is the drag force? Drag force is usually depends upon the viscosity, dynamic viscosity, then density of fluid, and the shape and size of the particle. When we are talking about the settling of the particle, the drag force usually depends upon the dynamic viscosity, density of fluid, and the shape and size of the particle. So the drag force by using the Newton's law can be written as, you know that formula for the drag force by using Newton's law. It is Fd is equal to Cd into A into rho into Vs square upon 2. This part is assumed that you have studied in applied mechanics and the fluid mechanics, and then we are taking direct formulas to solve the further equations. Okay. So the drag force Fd is equal to Cd into A into rho into Vs square upon 2. When we equate these two equations, why should we equate these two equations? Because the particle will settle at what stage? When the drag force and driving force becomes equal, is it? And for that velocity is known as the settling velocity. So to find out the settling velocity of the particle in a fluid, we need to equate these two forces, that is drag force and driving force. So the driving force equation you have written, rho s minus rho into g into v, and the drag force equation is cd into a into rho into vs square upon 2. Then by equating these two equations, you can find out the settling velocity of the particle. You can find out the settling velocity of the particle. So I request you to write on paper the Fd and F1 and equate these two equations and find out the equation for settling velocity, and let me know the equation for the settling velocity. Write down this slide first and then equate these two equations, F1 and Fd. Fd is the drag force and Cd is the drag coefficient. Drag coefficient, you know, the drag coefficient depends upon the Reynolds number. Okay. What is the relation between the drag force and Reynolds number? That relation will vary with the Reynolds number. If Reynolds number is in more than 10 raised to 3 or 10 raised to 4, then it will be considered as the turbulent flow, and in that case value of Cd will be different. When it is in a laminar flow, value of Cd will be different. Likewise, the value of Cd will change. It depends upon the Reynolds number. That further part we are going to see. But before that, after completion of this slide, you can note down, you can find out the equation for settling velocity by equating these two equations. And let me know that equation. At time being, I will take your attendance and then we will stop here today. And the remaining equation I will solve tomorrow on the board. Done this also? This one is also done?
Yes, ma'am.
Okay, tell me the equation. What equation you found? Vs is equal to? Yes, please. You can talk. Difficult to write that equation in chat box. So let me know what equation you did find. काढलं का equation? Have you done that workout? If not, you please do it. What you have to do? That F1 equate. This F1 is equal to rho S. This equation you can take rho S minus rho into G into V equal to CD into A into rho into Vs square upon 2. When equating these two equation and cancellation and solving all this material, you will get the equation for Vs. What equation you have sorted out, found? Or if not found, you can try now, or otherwise we will see in the next lecture on the board. I will solve. Actually, it is simple. That's why I have given you this task. You can try.
Under root 2 into rho S minus rho into Z into V divided by CD into A into rho.
Is your equation similar to this equation? Because your voice was getting to this equation? Not. Or maybe I. Is your equation in this format? Let me know who was talking first. I'm very much thankful to that girl student. Who was talking? Who was talking?
Yes,
Mansi.
ma'am.
Yeah, Mansi was there. Ha, Mansi. You have solved the equation and whether that equation is similar to this equation or not.
No, ma'am. Area value is not putting.
Area, you can put the value of area as pi by 4d square.
Yes,
Okay. And then you can solve it. Okay. I will, it's easy actually, but because this online forum, you may not be able to understand it fastly. But tomorrow I will show you on the board. Okay. We will stop here. I hope others also might have tried. Have you tried, guys?
Yes,
Other
ma'am.
students, please. Okay. What is the answer? What is the answer?
Same. Same.
Same answer. Okay. Then fine. No problem. Okay. So remaining part we will solve tomorrow. And then, so we will meet tomorrow. I have noted your attendance. Thank you very much, all of you. I will leave the class now.